Howdy. I'm probably too tired to make a video, but I somehow have to make it because I just stumbled across an article which is very interesting. What you're looking at is Birkeland Current here at the center of the picture, and you can somehow imagine Birkeland Current as a tube which usually would run like this through Earth. That's why we have the North and South Pole and the possible plasmoid at the center. Here we notice at the outer boundary of the Birkeland current we have hydrogen and oxygen. Of course, that's not to scale. This should be an overlay, and these different layers, there might be many more layers, and they might differ in size and stuff, and this should be from where we have water. Maybe the moho is some kind of water boundary between in our planet. Below the moho is no water anymore, or nothing related to water. Well, anyway, but it expands until we reach the outer edges of the atmosphere. So, in my recent video, I've just been talking about the hydrogen thing. At about 1553, I finally touched the possible hydrogen emissions related to cryptodome activities. And where is it? I think it's here in the conclusion section. The theory still needs much more exploration, but I think it is an important aspect to take into account in order to get the picture as coherent as possible. Maybe the hydrogen anion is the white rabbit. Through its negative charge and great abundance, it could be the root and source of all alkalinity, the reason for why the white rivers are white and why Earth is a blue marble. Earth's surface has a net negative charge, as earlier shown with Thornhill's repellent core, so it might be no coincidence that hydrogen accumulates at the surface, and it makes life on Earth possible. Yeah, because there's water. I also have been talking about sulfur. Here is, for example, my Finnish copper playlist, which probably still is going to be expanding because I'm about to make a video, but there's a little issue. I will tell you later what's the thing. But anyway, Finnish copper. Finnish copper might have its origin on Venus or from the interaction with it, or probably some other planetary body, or even a CME. The thing is, the sulfur. Let's just give me a second to search for some. Yeah, probably should take this one. A research council. Yeah, a research council. I wanted to show you this. I hope you have seen some of those microwave experiments with copper ores. And they are rather yellow. If you put them into a microwave, they turn red. So the question is, that's the coat of arms of Outokumpu, where we have a copper mine. Do we see it somewhere? I think I had the same problem some time ago. Kind of thunderbolts and all kinds of things. Yeah. Now here we can see it. So maybe this coat of arms design. The yellow stands for the sulfur, and the red for the sulfur after it's burned, because it turns red. It burns with a blue flame. And that's the sign for copper, and it's a sign for Venus as well. So, my claim that Finnish copper might have its origin on Venus or in the interaction with it, or with some other planetary body. Mars? I don't know. This is what I try to figure out. Copper is many times mentioned in the Kalevala. Brimstone is mentioned many times in the Bible. Brimstone is sulfur. Copper, its name originates from the island Cyprus. And also the Romans already knew that. And the Greeks. And so from the name Cyprus, it became coprum. And from coprum, it became copper. And many holy places like Jerusalem and others, they aren't too far from Cyprus after all. And they talk about brimstone and stuff. And there's the copper ore from Cyprus is very similar to the copper ore of Outokumpu here in Finland, which I find very interesting. So, sulfur, hydrogen. It's very interesting. The copper thing is still something under investigation, but I now want to show you an article I just stumbled across, and I decided that's so interesting how it correlates and resonates and goes along with the stuff I've been talking about. So this was released some 6 hours ago. We could say I'm somewhat up to date. Complex organosulfur molecules on Comet 67P, evidence from Rosetta orbiter in the lab. For those who know the Thunderbolts project, these pictures are very intriguing and revealing. The electrical comet. The Rosetta Orbiter Spectrometer for Ion and Neutral Analysis (ROSINA) instrument orbited the comet 67P to revolutionize our understanding of cometary material composition. A key finding of the satellites was to explore the composition of comet 67P Churyumov-Gerasimenko. In a new report published in Science Advances, Ahmed Manhoub and a team of planetary scientists in the Jet Propulsion Lab at Caltech. That's a rather big name. The Space Science Institute Colorado and the University of Bern, Switzerland. Who have guessed? But anyway, used the ROSINA data to study dust particles volatilized during a dust event in September 2016. The scientists reported the detection of large organosulfur species on the comet's surface. Then they conducted laboratory simulations to indicate the formation of this material from chemical reactions initiated by irradiating mixed ices containing hydrogen sulfide. Yeah, sulfide. It's sulfur in a form, or a form of sulfur. The results highlighted the significance of cometary sulfur chemistry and its presence in precometary materials to facilitate the detection of organosulfur materials in other comets and icy small bodies. Yeah, because many think comets are icy bodies. By using the James Webb Space Telescope. So if you just think back, my claim about Venus might be the origin of the sulfur. Maybe now we have it on comets. And Venus was the great comet. The serpent of creation. In Finnish Kalevala, at least, it is represented by Louhi. But anyway, when the Rosetta mission visited Comet 67P, the satellite revealed remarkable insights to the diverse molecules on the comet. The researchers detected organics by using a remote sensing instrument, visible and infrared thermal imaging spectrometry, and a series of instruments including Rosina Ptolemy and the cometary sampling of composition experiment. The measurements made using Rosina provided substantial information of the complex organic chemistry in cometary materials. Organic chemistry. Alongside further insights to the composition of the semi-volatile phases of Comet 67P. No, we don't. It's too late. 1 second video. Maybe we have time for 1 second video. Yeah. There's stuff going on the comet, which really cannot be explained by gravity. But that's just a side note. The measurements further revealed the detection of ammonium salts, or salts. In this work, Manhoop and colleagues discussed the data gathered from the Rosetta probe and Rosina during an event of enhanced dust impact on the instrument. Maybe electrostatics? They interpreted the data to reveal the presence of large organosulfur molecules with low volatility embedded in the dust of Comet 67P. The team completed in-lab simulations of the organic chemistry that began on the comet due to irradiation of simple ice mixtures in the presence or absence of hydrogen sulfide. I have been talking about hydrogen. I've been talking about sulfur. Now we are talking about hydrogen sulfide. The outcomes indicate the dominance of sulfur in the environment and a possible ice chemistry origin to the sulfur-bearing species on the cometary material. Yeah, I could say, I think, it seems like it could be very well possible that my claim that the sulfur has its origin on Venus isn't that crazy anymore. But let's go on. The dust event. Prior to landing on the comet, Rosetta flew elliptical orbits during the last few weeks of its mission with the pericenter altitude gradually lowered. On September 2016, the spacecraft reached its closest distance from the comet. It is assumed that the space probe was hit by a chunk of ice or dust prior to that, which led to the observation of high-density gas plumes for about 3 hours in the vicinity of the instrument. Yeah. What if this assumption is totally wrong and there were just electrical discharge events going on between the space probe and the comet itself? The measurements made during the study indicated the abundance of a variety of sulfur-bearing molecules prior to and after the dust event. The team conducted mass spectrometry measurements to identify carbonyl sulfide and carbon disulfide as species that did not significantly increase during the event due to their higher volatility. When compared with sulfur dioxide, which increased by about 2 orders of magnitude. yeah. 2 orders of magnitude. The team further monitored the presence of semi-volatile organosulfurous molecules on the surface of Comet 67P. Yeah, I have to admit I'm totally tired. I probably should have waited to make this tomorrow. But that's all just too exciting. Simulations in the lab, because now it gets even more interesting. The Rosina double focusing mass spectrometer, Rosina DFMS, data obtained during the dust event showed sulfur chemistry to be more complex and diverse than hitherto known or assumed via measurements. Anyway, that's a funny thing to say. In the undisturbed coma of the comet, Mahjoub and colleagues assumed this outcome to have resulted from the ice chemistry involving hydrogen sulfide. To explore this in the lab, the team performed electron irradiation experiments on ice mixtures in the presence or absence of the molecules. The experimental setup included a high vacuum stainless steel chamber, where the team deposited ices on a gold substrate attached to a cold finger. Gold finger. Of a helium cryostat through a gas to prepare gas mixtures. The setup included an electron gain in the chamber and a Faraday cup to monitor the electron beam current. So I have been downloading the paper, but I haven't read it yet. But I just wonder where they were. If they were like using electricity for the experiment. Electron gain. They charged it up. Does it mean this? I don't know. This might take some time to dive into that and read the paper and think about it. But anyway, let's go on. I can go to sleep after this. The team detected the evolving samples with a Fourier transform infrared spectrometer. Further experiments highlighted the rapid dissociation of hydrogen sulfide in the setup, compared to methanol and water samples used in similar experiments to produce a high concentration of reactive sulfur-bearing radicals to predominantly affect the chemistry in the ice films. Outlook. In this way, Ahmed Mahjoub and his colleagues characterized organic heteropolymers in small interstellar icy grains and icy bodies. They assumed hydrogen sulfide ice chemistry to be likely for the observed species. They highlighted the presence of other pathways to form organosulfur compounds in the diffuse interstellar medium and in the solar nebula. Using in-lab simulations, the scientists showed that sulfur-bearing organic compounds could be formed via sulfur ion bombardment of astrophysical ices containing carbon, oxygen, and nitrogen constituents. We have to remember that, at least by now, Venus's atmosphere contains quite much sulfur. This might tie also very nicely into the whole. The James Webb Space Telescope incorporated during this work can increase the understanding of the chemistry of the solar system, including comets and asteroids. This instrument can also assist researchers to unveil the composition of a variety of such interstellar bodies alongside their similarities or differences, to understand the formation and evolution of the solar system, where sulfur chemistry is of interest. Yes, here it is. Copper mines all over the place. The surface conductivity anomalies. Microwave experiments. And so on. The fate of sulfur has a key role in the evolution of comets and interstellar icy bodies, maybe also planet-sized planetary bodies. Although much of its role in the building blocks of the solar system remains to be known, or maybe unknown. Although much of its role in the building blocks of the solar system remains to be unknown. Yeah, you can correct me on that, but I assume there is a typo. Unknown and not known. Remains to be known. There must be a mistake. But anyway, this is just what I think. The element, however, holds promising capacity to answer the origin and evolution of such icy small bodies, and probably to many other things too. Here you can download the paper. I will put some links below. Check them out. With sulfur, without sulfur. Yeah, like I said, it's too late for me. I shouldn't probably have done this video now, but anyway, now it's done. I will go to sleep, and yeah, thanks for watching. Bye.